Sir, I didn't get any link, sir, because today only my first class, sir.
Okay, you join in the Google Classroom, uh, right? I have also
No, sir, I
created a
didn't.
WhatsApp group. I think Manasa has done that. This, you contact her
Sir, sir,
and you
I asked.
join in the WhatsApp group. You will find the code for that GCR also in that. So with that, you can join in the
Okay, sir.
Google
Okay, sir.
Classroom. Okay. Thank you, students. Thank you for joining for the today's session. And I hope you will be remembering at least some concepts which we discussed in the last year, some basic introduction about machine learning. And today, whatever we are going to see is the last class on the introduction topic. So from the next class onwards, I will be going into the technical contents a bit more. So I want you people to have some information on the background of this concept of machine learning. Right? Maybe you would have forgotten all those things. No issues. I have uploaded the PPT in the Google Classroom, and today also I will upload it. So before coming to the next class, you just have a complete idea of what we are talking about, what we are learning on. Then when you come to the next class, it will be easy for you to follow. If you have any doubts, if you have any queries, you can ask me then and there. Even if we have a WhatsApp group, you can share your queries or doubts there. Maybe it will be useful for others also. Let us go into the today's session. Is my screen visible?
Yes, sir.
Okay. So history of machine learning, right? So in the previous two classes or three classes, we discussed about the theological aspects of machine learning, the ethical values of machine learning, or in other words, we can plainly say why we should study machine learning, or as an ECE engineer, how machine learning will be useful for you. So these are the contents which we discussed in the last session. Now we are going into the concepts of the technical concepts of machine learning. So before going into that, it will be always good for you to understand the history of machine learning, how this concept of machine learning evolved. So the seed for this machine learning, or ML, was planted in the year 1950. Samuel Checker's playing program. You see, always keep in your mind that machine learning, if you ask me to show me machine learning, I cannot show you. It is still available in the form of a program in the computer. Once it is ready in a full-fledged manner, then some people or some researchers may take it and put it or dump it to an IC chip where we can get it in the form of a product. But these programming concepts of machine learning, this started in the way back in 1950. In 1952, Arthur Samuel, he was the one who was the pioneer for this concept of machine learning. Right? He created a program for playing checkers. Right? I hope most of you would have played this board game of checkers. So the main objective of that program is to observe the positions at the game. Right? Observe the positions at the game. Maybe I can show you. The checkers game board. I think I have in my presentation. Yeah, this is the checkers board. Right? Some people may call it as Chinese checkers also. So it is about when I make a move, what move the other person is going to make. So depending upon the moves we make, we are going to judge on a winner. So what happened in 1950 is normally this checkers game is played between two human beings. But this person, Samuel Arthur, he devised a program in 1950 or in 1952 for playing checkers. That means a human being can play a game with a machine. So the program, the main objective of that program was to decide what move should I make. when a human being make a move, so what move should I make so that I can win the game, right? So in other words, you can say that the machine or the program is going to learn. So when I make a move, I have plenty of moves to make. So depending upon the move I make, the machine is going to learn. Okay, if this person is making a move in the left hand side direction, if I make a move, what will happen? That process is called as learning, and the complete output is called as model. Right? Once I am very confident of making a move for all possible positions a human being can make, then I can say that I am going to win the game at all times. So he was trying to develop a model in the sense a complete setup for winning the game in the form of a program or a machine. So the system, how it is going to learn, the system played many games with itself, right? Or sometimes with another human being, and observed that the program was able to play better in the course of time. That means each time it learns, its performance is getting improved. That is very, very important. Learning doesn't mean that you learn something, by heart something. No, that is not at all learning. How you are going to reproduce, right? How you are going to improve, how that learning is going to be useful for you. That is very, very important. That is called as learning in a real life. You learn many subjects in ECE. After final year, what you are going to do, how these subjects are going to be useful to you, right? That is the main purpose of that learning. So we need to improve, and Arthur Samuel found out that the uh, machine's performance improved with the course of time, with getting more experience means it is going to learn more from the different possible varieties of moves a human being is going to make, or the operand is going to make. And Samuel coined the term machine learning. So the concept or the word or the term machine learning was originated in the year 1950, or exactly 1952. So a machine is going to learn based on the experience, and that we call it as machine learning. And he defined learning as a field of study that gives the computers the ability without being explicitly programmed. That means independent decisions. Independent decisions. You need not program a machine or a computer anytime. It is going to take a decision based on the past experiences. Then in 1960, this was the 1950 was the seed, we can say. Based on this, in 1960, there were many other machine learning techniques developed by many scientists or researchers. Because whenever we develop something, we need to show the world that I have done something, right? So that we have many research venues. People say publications and research papers. Maybe you may not understand that now. When you come to your final year or when you come to your MTech, you will know better. Right? So when one person develops something, immediately it will tempt the other people. Right? There were so many researchers and they were copying what Samuel Arthur was doing. And based on that, they developed many methods. And one important method in the 1960s, neural networks, right? Neural networks, most of you would have heard about that. It is one type of machine learning approach. And that too, in neural networks, the first framed neural networks is called as perceptron. And Rosenblatt developed that method. And when neural networks were developed, pattern recognition came into existence. Pattern recognition is one of the interesting field in the area of computing, right? Pattern. What do you mean by pattern? We normally say the pattern in a shirt is a line or a check or a broad check or a small check or plain shirt, or whatever it may be. Right? That is called as a pattern. Or in other words, you can say that when I'm seeing this laptop screen, this is a pattern. Only if I recognize that this is a laptop screen, I can do some operations with this laptop. Right? For a human being, that doesn't make much importance. We are not going to give importance for that. But when we ask a machine to do some work, first it must recognize what is what, right? Whether it is a cat or a dog or a lion or a tiger or an aeroplane or a lathe machine or a cement brick. Only if it recognizes first, as we do in our real life, then it can do some operations with that. So in 1960, this pattern recognition was booming in a larger manner because of the availability of machine learning techniques which support pattern recognition. Pattern recognition is an application which is carried out well with this machine learning techniques. But what happened in the latest year of 1960 is there were two scientists called as Minsky and Pepper. They proved some limitations or drawbacks of perceptron, which we will study later. So because of these drawbacks, neural networks stopped, or otherwise I can say that the researchers stopped working with neural networks. Then came 1970, and in 1970, another broad area of machine learning called the symbolic AI came into existence. So symbolic AI means if I say that there is a cat in the tree, right? If I say that there is a cat in the tree, can you imagine in your mind a tree and a cat in the tree? Each one of you is going to imagine in a different way, right? So that is called a symbol. That image is called as a symbol. Your cat may be different from another person, another student's cat. Your tree may be different from another student's tree. Right? So this is one of the earliest possible technique by which we say that machine learning concept originated. Right? So with the help of this mind concept of a normal human being, we created many symbols. We have a car, we can have a car image, and we have a plane, we can have a plane image, or you can have a signal or any other data. Any other data can be represented for a specific input element. Right? But what happened is there is a drawback with symbolic AI. The thing is, a cat, which a student maybe Mohammed thinking about, is not the same exactly as Ronan's cat. Right? They may be thinking on two cats. But when a machine is going to find these two symbols given by Ronan, Joshua, and Mohammed, it will have a problem because it will may encounter infinite number of cats, different types of cats. So generalization is not possible, or I can say that it is very difficult with symbolic AI. Then to solve this, we had another concept called as expert systems and knowledge acquisition. So how we can say that this is a cat, how we can generalize a specific object that came into existence. And with the help of these expert systems, decision tree approaches came into existence. This decision tree is a very important machine learning approach. Neural network is one machine learning approach, and this decision tree is another machine learning approach. You would have seen a tree, right? You will have root, we will have then stem, then we will have branches, and then we will have the leaf stalk, then we'll have the leaves, the fruits, and the end products. In the same way, when you have a complete knowledge, a knowledge about a cat or the information about a cat, we can group into different branches, right? Whether this information is necessary, whether it has four legs, then there is a chance that it may go for it may be a cat, right? Whether it is white in color or whether it is full black in color, then the chances of that animal being cat is more, right? Whether it has paws, whether it says meow, right? So many information you can derive from a single data, and finally you can come to a conclusion, or you can come to a decision that it is a cat. So this is one type of approach which solved the problem of symbolic AI to some extent, right? We can generalize it to some extent, but fully you will not be able to do. Then came 1980, where we have many advanced decision tree approaches and rule-based learning approaches. And in 1980s, there was a resurgence of neural network. I told you in 1960, there were many drawbacks with neural networks, specifically with perceptron. But in 1980, there were a few other scientists or researchers who worked on these specific concepts of neural network, and they told neural network can be much useful, or they said that it is one of the brightest possible machine learning approach which can be useful for all applications, right? They framed a technique called as MLP, multi-layer perceptron. The perceptron which I gave you earlier is the single layer perceptron, but they gave another concept called as multi-layer perceptron, and that became a very big success that overcame the drawback of perceptron, and till now it is being widely used. And you would have heard the word deep learning. right? Deep learning is completely based on artificial neural networks, and that too specifically, the spinal cord of deep learning is multi-layer perceptron, which was invented way back in 1980. Right? So there are many machine learning techniques. Then in 1990, we had the concept of support vector machine that is more or less statistics based. Right? Statistics in the sense you will have some predefined data. Say, for example, the traffic situation in Coimbatore. Maybe from 8 to 9 morning, it may be the rush may be high because of the office goers and the school goers. From 11 to 12, it may be less. Again, it may the traffic may go to the peak state in 4 to 5 or 5 to 6, something like that. So these are some statistics. So with that statistical data, we have many mathematical approaches which are used for deriving the information. One such technique is called as support vector machine. I think we have a complete chapter dedicated for this support vector machine. This is another machine learning technique. And then with the help of support vector machine, we came into the concept of data mining, where we say that we can get many information, right? Jude is teaching a machine learning, right? This is a simple sentence. But when we say data mining, how much information can you derive from that? When you say that Jude is teaching machine learning, then Jude must be a teacher. Right? Jude must be a teacher. If Jude is a teacher, then he should be working or affiliated to some institutions. He cannot be an independent teacher in this scenario, right? And he's teaching machine learning, so he must be good in artificial intelligence and related subjects. So these are some informations which you can derive. A human being can derive, but how a machine is going to do when you give a simple sentence or a simple data? That concept is called as data mining. So this data mining and pattern recognition both are applications which are well carried out by this machine learning techniques. Then we have the adaptive agents and the web applications, right? Nowadays, everything has gone only via www, right? And specifically, we have the concept called as chatbots, the speaker translation methods. Right? So that also came in 1990. Then text learning, the signature identification. Nowadays, there are so many forgeries going on in the banks, the transactions, and many other areas where the text data come into picture. So machine can learn and solve that problem. Then another important breakthrough in machine learning is called as reinforcement learning. Reinforcement learning, where you will get some feedback whether the learning, the way in which you are learning is correct or not. Then ensemble-based learning, we call it as AdaBoost, random forest. These are some types of machine learning techniques. Then Bayes net learning. So these are in 1990s or maybe till 2000. After 2010, only one person. There is a common proverb, right? In one city, there can be only one king. You can have only one sword in your pocket or something like that, right? In the same way, even though there were many machine learning techniques from 1950 to 2000, one person, he became the king or he became the champion, who is none other than the artificial neural networks. All the other methods are found to be inferior to this specific artificial neural networks. Now we have the advanced representation of artificial neural networks, which we call it as deep learning. With the arise of deep learning, we have the concept of GPU also coming into picture, because deep learning is very complex. Right? Deep learning is very complex. The number of layers, the computational complexity is very high. So system cannot do. Remember, our machine learning is a program. So program in the sense it should be executed only within a computer. So when you go to go to the support of a computer, you must be very sure that how maximum capacity the computer is made up of. If not, again, your system is going to hang. So to solve that problem, we have this concept of GPU, graphical processor unit, right? A normal computer will have CPU, but if your speed will be high, how it is going to do that? With the help of another concept called as parallel processing. That means, remember, you would have done some program, maybe in C or C++ with some for loops, right? For I is equal to 1 to 3 or 1 to 4. So what happens is the same program will be executed in your CPU for some 5 minutes or 10 minutes. But when you have GPU or parallel processing structures, what can happen is I is equal to 1 can be done in a single processor. I is equal to 2 can be done in another processor. I is equal to 3 can be done in another processor. I is equal to 4. But parallelly, they are going to do. So you cannot see that. But when you get the result, it will be same as that what is being carried out in CPU. But the time taken will be less because it is being done parallelly. Now, deep learning, GPU, now we have edge computing, then we have the cloud computing process where in cloud computing, your complete machine is going to be taken care by the cloud. Because if my data is huge when I go for a machine learning program, right? The system capacity, if I have only a low spec laptop, I cannot process completely that. So what I can do, I can buy a cloud. Many clouds are available for purchase. You can buy a cloud, and the entire machine or the entire processing will be done in that cloud. You will not see that. You may think that it is being carried out in the laptop, but when you enable a command, automatically all the processing where their specification is going to be high. Right? The cloud processing can be done, or cloud computing can be done, and the results will be given back. This is another important breakthrough in the area of AI and ML. And then we have the concept of big data. Right? We have the concept of big data. As I told you in the first class, data is very, very important for any machine learning approach because we are going to learn from the past experience. So when you say big data, the data available in today's world is huge. So we need to have machine learning techniques which can satisfy the amount of or the quantum of the data. You take a Facebook, right? You take a Facebook every day. I hope every one of you will be using Facebook, right? You will have the text data, you will have the image, you have the video, many things are available. Imagine how many people in this world are using Facebook. Right? In a day, it has been estimated roughly that around 200 terabytes of data is originated from Facebook. That's why they say that this person is leaking all the data, the confidential data to some other third party, something like that. Imagine the amount of data. You take a normal air travel. You take air travel from Coimbatore to Delhi, right? It has been again estimated for a 2.5 hours travel. Roughly, there is uh, 10 there are 10 terabytes or around 20 terabytes of data generated. The pressure, the capacity, how much intensity, the speed, the velocity, the blade movement, everything is being recorded. So if a machine learning wants to do some prediction, the data it has to deal with is going to be huge. So big data is another concept which is very much related with our machine learning. So these are some of the stuffs, some of the methods which have been developed, which has been evolved. And in today, we talk about deep learning, GPU, cloud computing, and also other concepts. Right? But when you go for machine learning, these are supportive information which will be useful for you people. We are going to see all these methods in detail in our later chapters also. So when you say talk about the application in 1994, the first self-driving car made a road test. We are talking about autonomous vehicle only now, but in Western countries in 1994, right? I'm not sure whether you were born at that time. In 1994, the first self-driving car made a road test. We are not bothered about whether it is a success or a failure. Don't worry about that. First time, definitely there will be scope for improvement. In 1997, another game like Samuel Arthur developed, copying him, many people developed, and Deep Blue bet the world champion Gary Kasparov in the game of chess. Right? Gary Kasparov is one of the famous chess player during when I was a child in the game of chess, and it created a huge wave that a machine defeated Gary Kasparov based on the experience it gained. In 2009, we have Google building self-driving cars, autonomous vehicles. In 2011, Watson, again from IBM, won the popular game of Jeopardy. Jeopardy is like a business game. It's like a gambling game where again it's a program where again they won, machine won. And now in 2014, we see human vision surpassed by the machine learning systems, right? How we see, that's what I told you in the first class. how we see the same process can be incorporated in the machine learning also. Emotions, right? Whether I'm happy or not, that can be also incorporated in the machine learning system. Nowadays, we much talk about machine translation systems, not only recognition, how we can translate it. Now, due to the COVID situation, education has become virtual in most of the cases. So, in that case, can I have a class here which can be attended by people from all over the world? A Chinese person, right? Yeah, an African person, and an English person is good in English, but a Chinese and an African may not be good in English. Can we go for some translation systems? Can I go for creating something of mine artificially? I may not be present physically there. Right? Augmented reality, virtual reality, haptic technology. These are many recent developed technologies which are coming out now. Right? Everything is towards a same common principle. What is that? Creating that artificial human being. So these are supportive elements. An autonomous car is a supportive element, so that when an artificial human being comes, it will be easy for him to go a ride in that specific car. Nobody knows whether it will be a success or not, but still we are doing all these things for the benefit of the human society. So these are the introduction about that. This is a small slide which I think you must know. Difference between an algorithm, program, and ML. I told you ML is always a program and algorithm which is inside a computer. Right? But there is a small difference between these two. When you say an algorithm or a program, right? Computer is there. Computer is the main thing which is going to process. No doubt in that in both the cases. But the inputs to the computer is the data, right? Say for example, you were asked to write a calculator program in your um, uh, exam, right? We are given 2 plus 3, so 2 plus 3 is the data. The computer gets that, and what you will do is you will write a program based on a language. You will go for a C language, C++ language, or any language. You will write a program, and you will get an output of addition, subtraction, multiplication. But in machine learning, right? In machine learning, what happens is it is completely reverse, right? Take the data. Data is fine. Computer is fine. The other two elements are reversed. Sorry, I made a mistake, I think. And the computer output is not actually output. The program will be the output, right? Data will be there. Along with the data, the other input is actually the output. Right? Face recognition. When I want to create a program for a face recognition, it means for all faces, I must be able to recognize the faces. So when I give a face image as input as data, I will also give that this is Jude, which is the actual output or the target of that image. Right? Then if I take another Abraham Lincoln's image, I will give Abraham Lincoln. Then when I take Barack Obama, I give Barack Obama. Lionel Messi, I give Lionel Messi. After seeing all these images, right, the data and their outputs, the computer is going to give some output, which is called as program. That is what we call it as program in machine learning. That program is also called as model. This program is capable of doing face recognition for all input face images. You got it? The difference between a machine learning program and a normal program. In a normal program, you keep on changing the program. The main emphasis will be on the program. But when you go for a machine learning, if I say face recognition program, it is set. It is set. You need to only change the data, only change the face and check the output. Right? So in machine learning, the program is more or less called as a model, which is going to do the same task. Say, for example, face recognition for different inputs. But in your algorithm or normal computer program, it is something different where the program is going to completely change depending upon your data and the necessity. But here, for an application, it is going to be fixed. Right? So this understanding you must have when we go to the subsequent slides. So based on these concepts, right, I gave you a normal definition in the previous class, but Tom Mitchell, who is considered as one of the pioneer in the area of machine learning, he gave a technical definition for machine learning. If you can understand all the concepts which I told you earlier, then this definition is going to be much more easier for you. A computer program is said to learn from experience E. What is this experience E? Data, the past data, the previous history, right? With respect to some class of task, right? What task? If it is a face image, I'm going to do face recognition. If it is a speech signal, maybe I'm going to do speaker identification. If it is an MRI image, the past experience is an MRI image, I'm going to do some medical diagnosis. Right? So when I say data, it is not going to be useful for all tasks. The data for some task. Right? So said to learn from experience E with respect to some class of task T and performance measure P. That means when I do face recognition, the accuracy is important. The learning process is important. I cannot say give my image and say this is Abraham Lincoln's output, Abraham Lincoln's name as output. That is wrong. Then my model is not performing in the best possible way. Right? So what are the three components which is important? Experience C, the past data, and the associated application, which I'm going to call it as task, and then judging the performance of that process. Right? How much good your recognition system or task has given. Right? This is called as machine learning. But the condition is if its performance improves for that specific task, for that specific performance measure P, and for that experience E. All right. If your performance is not improving, then it is not learning. There's no concept of learning. That's why we are giving much importance to the performance measure P. And there are many performance measure. Maybe if I am asked to pick the best student in your class, right? I cannot blindly do that. I will ask for what is the performance measure given to me. Is it the total mark in a machine learning subject, or is it the rank, or is it the CGPA, SGPA? All these are performance measure. So when you go for a machine learning, you should specify the performance measure because your output may change depending upon the performance measure also. So now you read the definition. A computer program is said to learn from experience C with respect to some class of task or operation and performance measure P if its performance improves. The three components are experience, the past data, the task application like prediction or calculation or estimation, any operation, and performance measures. I'll give a small example for this concept of machine learning. Right? Imagine you have some set of pair of numbers 2, 4, 3, 6, 4, 9. Then you put only one number of the pair. In 2, 4, you are taking only 2 and giving into a machine to predict the other half of the pair. Right? Then how it is going to do? So what it will do is it will first try to find out the relationship between 2 and 4, 3 and 6, 4 and 9. Right? There may be some relationship. That's what it is going to learn. Once it learns that, then it will be easy for the machine to predict the second number 5. How we do? Exactly the machine is going to. Right? So this logic is called as machine learning. So you'll have the past experience. What is the past experience? 2, 4, 3, 6, 4, 9. These are the data, which are the past experience. And what is the task? Prediction. Prediction is the task. If I give 5, what could be the number? Right? If today's gold rate is 4,900 per gram, what will be tomorrow's rate for that gold? Right? And the performance measure is also there. Accuracy can be the performance measure. How accurately I am going to judge the rate of the gold for tomorrow's in tomorrow's scenario. So these are some other practical examples in the Chinese checkers game. You have an experience, you have a task, you have a performance measure. Never ever forget this. ETP. When you are doing some project with machine learning also, you must have some past data. You must have an objective or an application. Then you will have some performance measures on judging how the machine learning method is working for your specific application and for that specific data. And this is one example for a handwriting recognition. What is the task? The task is to recognize correctly the handwritten words. Maybe if you go to your bank Only if you have a scanned handwriting signature available, they will give you the cash. What's the performance measure? How correctly it has been classified. The stroke in which I put my signature, whether it matches with that, you can correct. What is the experience? You must have a previous history of my handwriting. Otherwise, how you will do? You will not be able to do. A database of handwritten words with given classifications. In the same way, for a robot driving learning problem, right? How it is going to, the task is maybe driving on a public 4-lane highway. And the performance measure is how much distance it traveled before it encountered an error, right? Because it is like an autonomous car where how much distance it has traveled, it can be a success. Today, if it is traveling 2 kilometers, tomorrow, if it is able to travel 200 kilometers, then I can say it's a success. It's a performance measure. And what is the experience or the data which is necessary for them? A sequence of images, right? And the steering commands which is recorded are observed by a human driver. How a human driver see when he sits before the wheels, the same images, same patterns should be given to the car. Without that, nothing is possible. So experience, task, and the performance measure. If you have these three things, you can do plenty of works with machine learning for all sort of applications, not only with related with ECE, anything else. So this we will continue in the next class, right? So kindly go through that PowerPoint, because these concepts are still under research, which may say that a concrete evidence may not be available, highly debatable, right? Whether it is going to give or not. Even for some works it may give, for some other works it may not give. So if you want to learn machine learning in the best possible way, go through the contents, go through some blogs or websites. You may have some free time, and then we can have a discussion on that also. Let me mark the attendance. Amulya,
Yes, sir.
Judson, anybody writing the chat box? Judson not there. Okay. Samyukta,
Present, sir.
Angel,
Present, sir.
Ajit, Ajit, Glory,
Sir,
Yes.
sir,
Kiran Kumar, not there. Manideep,
present, sir.
Bhanuteja, if you don't delay in giving your attendance, then I will get confused and it may take more time also. Right? See,
Sir,
some
net problem, sir. Sorry.
okay. Kiran Kumar is there. Glory, Glory. I called out the name. Kiran Kumar. Kiran Kumar not there. Claudia. Claudia. Okay. Priyadarshini.
Yes, sir.
Afreed.
Present, sir.
Jayant.
Present, sir.
Vikas.
Present, sir.
Paul Finney.
Present, sir.
Bhuvaneshwar.
Present, sir.
Ramesh Kumar. Ramesh Kumar. Absent. Neeraj Kumar.
Yes, sir.
Zubair.
Present, sir.
Kirti.
Yes, sir.
Dinesh.
Present, sir.
Tejaswant.
Present, sir.
Yes, sir.
Priya.
Present, sir.
Karthik.
Sir.
Janish. Jenish. Jenish absent. Okay. Rex.
Yes, sir.
Harshavardhan.
Present, sir.
Uday.
Yes, sir.
Mohammed Saqib.
Present, sir.
Siddharth.
Yes,
Praneeth.
yes, sir.
Salomi.
Yes, sir.
Libinson.
Yes, sir.
Alan.
Yes, sir.
Ronan Joshua. Sai Kiran.
Yes, sir.
Yoshiba.
Yes, sir.
Shiny.
Yes, sir.
Jasmine.
Yes, sir.
Celestine.
Yes, sir.
Jayasurya.
Yes, sir.
Manasa.
Yes, sir.
Ashrita.
Present, sir.
Narasimha Reddy.
Yes, sir.
Puneet Kumar.
Yes, sir.
Shiny. Joshua.
Yes, sir.
Nagakiran.
Yes, sir.
Suraj. Suraj absent. Monica. Monica absent. Taufik. Okay. Manideep.
Present, sir.
Two Manideeps are there. I think. Dikshit.
Yes, sir.
Dikshit.
Yes, sir. Yes, sir.
Angel. Maria Angel.
Yes, sir. Yes.
Amrut.
Yes, sir.
Avan Kalyan.
Yes, sir.
Sainath. Jagat Chandra.
Present, sir. Present, sir.
Shashank. Gopichand.
Yes, sir.
Ritvik.
Yes, sir.
Solomon.
Yes, sir.
Sudarshan. Sujit.
Yes, sir.
Suresh. Sunny.
Sir, 98 present, sir.
Present, sir.
Pardon? Sunny is there?
Yes, sir. 144.
Okay.
Sir, 98 present, sir.
Let,
Network
let,
problem.
let, let me read out the absentee's name, then you can let me know. Okay.
Okay, sir.
Maunika is there?
Yes, sir.
Okay. Suraj, Ashish, absent. Then Jenish absent. Kiran Kumar. Kiran Kumar is there? Okay, Kiran Kumar absent. Then Judson absent. Okay, thank you, students. You can leave the Google Meet.
Thank you, sir.